My name's Suzy Moat. I'm an assistant professor of behavioural science at Warwick Business School. And I'm extremely happy that Marcus invited me to come and speak here today. So my background is a mixture of computer science and psychology, which until recently, I think a lot of people thought was a bit of a strange combination. But as many of you in this room will understand, things have really changed in the past few years. And increasingly, everything we do is generating data. From whether you're just buying bread in the supermarket with your loyalty card, or maybe you're taking a ride on the tube in London with your Oyster card, or perhaps you're just calling your friend for a chat. Now, what I'm particularly interested in is data from the internet. So data on what we're looking for on Google, for example, or what pages we're looking at on Wikipedia, or who's talking to who on Twitter. With my colleague Tobias Prijs, I direct a data science lab at Warwick Business School, where we investigate whether we can use these kinds of data both to measure how people are behaving in the world right now, and possibly even anticipate how they're going to behave in the future. So let me give you an example. We were particularly fascinated with the global breadth of data from Google. Never before have we had an opportunity to understand what people are looking for over the world as a whole. But there's a problem in trying to compare what people are looking for in different countries, because people tend to search in different languages. Thankfully, one day, we had a moment of inspiration, and my colleagues, Tobias Prijs, Jean Stanley, Stephen Bishop, and I realized that there is something which is reasonably universal between languages, and that's the year in Arabic numerals. So 2014, 2015, 2013, for example. And so what we realized, what we did is we took data from 2010, and for all countries across the world with more than 5 million internet users, we measured how often they were looking for the next year, 2011, and how often they were looking for the previous year, 2009. So on this map, countries which are coloured in blue were looking more for the next year, 2011, and countries which are coloured in red were looking more for the previous year, 2009. Now, if you look at this map, you might recognise a pattern. Some of the countries which are coloured in blue, like the UK, Germany, Australia, for example, are places where people who are reasonably well off tend to live. Whereas some of the countries which are coloured in red don't tend to have inhabitants who are quite so well off. So to investigate this relationship a little more closely, what we did is we created a future orientation index, where for each of these countries, we divided the number of searches for the next year, 2011, by the number of searches for the previous year, 2009. And we combined this with a measure of per capita GDP for each of these countries. And what we found was that internet users in countries with a higher per capita GDP were looking for more information about the future. Now, there's a number of reasons that this could be the case. It might be that greater economic success could lead to, could give you more cognitive resources to focus on the future, or that a greater focus on the future might lead to greater economic success. Or equally, it might be the case that people in countries with a higher per capita GDP tend to use the internet more to look for more information about the future. They tend to expect that there's more information which will help them make decisions about what they want to do in the future. And at this point, I'm going to have to ask Marcus for help, because this keeps auto-forwarding.
I'm sorry.
keeps you on your toes at least, but right, fantastic. Okay, thank you, Marcus. Okay, so that last point brings us to an important observation. Often when we're using the internet, we're looking for information to try and help us decide what we're going to do in the future. And there are a number of areas where it would be very useful for us to get a better understanding of what people might do in the future. And clearly one of these is the stock markets. Now, changes in the stock markets obviously don't just affect traders. For example, the big fall in stock market prices in 2008 had repercussions for people throughout society. And so what we wondered is whether we might be able to combine information on what people are looking for online with data, with what's going on in the stock markets, and whether this information on what people are searching for online might be able to give us a clue as to what was going to happen next. So to investigate this hypothesis, we took data from Wikipedia. Now, most of you probably realize that Wikipedia makes information on its pages available for free. But what you might not know is that you can also get information on how many people have been looking at these different pages. And so we took this data and we used it in a hypothetical trading strategy where we were trading on the Dow Jones Industrial Average. And this is how this strategy worked. So consider data on how often people have been looking at a page about a company listed in the Dow Jones, like the Bank of America, for example. So we would look at how many people had clicked on that page in week T, and we'd compare it to how often people had looked at that page in the previous few weeks. If we found that fewer people had looked at that page this week, then we'd buy stock at the beginning of the next week, and we'd sell it again a week later. If, on the other side, we found that the number of clicks on that page had increased in this week, then we'd sell stock at the beginning of the next week, and we'd buy it back a week later. So we didn't just do this with one page. We did it for pages on all 30 companies which are listed in the Dow Jones. So IBM, JP Morgan, for example. And using data which Wikipedia gives us from the end of 2007 onwards, this is what we found. Increases in people looking at those pages tended to be followed by stock market falls. So let me explain this diagram to you in a bit more detail. In grey, you can see what would happen if in that period you had been trading randomly. So each week there was a 50% chance that you might sell, a 50% chance you might buy, and a decision in one week was not related to a decision in the previous weeks. And you can see that with this strategy, sometimes things would work out well, you'd make a lot of money, and on other occasions, you'd lose everything you'd invested. If you look in blue, you see the distribution of returns from trading on this Wikipedia data. And you can see that that is significantly shifted to the right. And so we find that using that data from Wikipedia would have given you significantly higher returns than just trading using this random strategy. Now, we work with an excellent doctoral student, Chester Kerm, who's based at Boston. We had the pleasure of having him at Warwick over the summer. And he pointed out, well, we don't just have data on how often people are looking at these pages, but we also have data on how often people have edited these pages. And so Chester collected all of this data, and he put it into the strategy that I described to you before. And what we found was that actually the returns from using this edit data were no different to the returns we would have seen from trading randomly. So it looks like there's no value in the edit data in terms of anticipating upcoming stock market moves. And this might be for a number of reasons. So if you consider how you and I use Wikipedia, people tend to look at Wikipedia pages much more frequently than they edit them. So we have a lot more data on how often people have viewed these pages than on how often people have edited these pages. On the other hand, this might just be due to the fact that there's a big disconnect between the kind of people who are editing Wikipedia pages and the kind of people who are having any influence on stock market moves. So this was good. It worked for 30 pages. But we wondered, well, will it work for a bigger set of pages? And so we considered 285 pages that Wikipedia editors had labelled as being related to general economic concepts. So pages on topics like capital, or macroeconomics, or wealth, for example. And this is what we found. Exactly the same as before. Increases in people looking at those pages tended to be followed by stock market falls, to the extent that we could use our strategy to gain significant profits in comparison to the random strategy over the period we analysed. Again, the edit strategy doesn't work out, so we find further evidence that there is no information in the edits that we could use to anticipate upcoming stock market moves. So this was good, but we had a sneaking feeling, what if it works for just any old Wikipedia pages? That wouldn't make a lot of sense. So we tried to trick the strategy, and we took data on something which we considered to not be financial at all. So data on pages about actors and filmmakers. So people like George Clooney or Sandra Bullock, for example. And we put that into the trading strategy instead. And this is what we found. Thankfully, absolutely nothing. So if you try and trade on that data, you get pretty much exactly the same results as you would have got just by trading randomly through that period. So we've seen these results with Wikipedia, and we tried exactly the same strategy I explained to you before, using data on how often people had been looking for different words on Google as well. If I show you the results from 98 words that we originally looked at, we find a similar pattern at first glance. So our best performing keyword was debt, a word that seems to have obvious connotations to the financial markets. Whereas if I pick a less financially related keyword, such as culture, that didn't perform as well. Now, this result's very appealing, that the best performing keyword is debt. But most of you will realise, sadly, we can't really conclude very much from that. It's just one word. It's not clear we would have been able to find it in the first place. And so our real question was, we wanted to look across all of these 98 words and ask, what makes a keyword successful? So if I look at a few more examples, you do find words which are in line with the pattern that we saw before. So words like stocks or credit, which are clearly financially related, performed well, whereas words like garden or train wouldn't have worked out so well. This is still a bit hand-wavy, and we wanted to work out how can we quantify how financially related a word is. And so what we did is we looked at how often each of these words could be found in the Financial Times. Now, the Financial Times obviously writes about financially related topics, and so you'd expect financially related words to turn up more often in the Financial Times. On the other hand, the Financial Times writes in English, so you'd also expect words that turn up frequently in English perhaps to turn up frequently in the Financial Times. So what we also did is considered how often Google could find each of these words on the internet as a whole. And we used that to normalize our Financial Times measure. And what we found in this study was that the returns were significantly correlated with this indicator of financial relevance. So increases in people looking for more financially related terms were more likely to be followed by stock market falls. So across Wikipedia and Google, we've seen that increases in people looking for financially related information tended to be followed by stock market falls in the period of analysis. We wondered, is it really that simple? It's just about financial information. We're sitting on an awful lot of data here. And so we thought, we'll try and turn the question around. We'll ask instead, what do people search for before stock market falls? And so again, with Chester, we processed all of Wikipedia to pull out 55 groups of words with similar meanings, where these topics spanned a range of things that you would come across in everyday life. Now, obviously, we didn't do this by hand. It would take far too long, and it would be subject to our decision as to what's related to each other and which topics we should pull out. Instead, what we did is we built on an observation that words which have similar meanings tend to be found in documents together. So, for example, if you look at a Wikipedia article and you already know it's got the word debt in it, then it's perhaps more likely for it to have the word money in it. And so using this observation, there are well-known algorithms, for example, LDA, which some of you may have heard of before, which can be used to pull out topics in a corpus of text. So we took our 55 groups of 30 words, and we gave them to people on the internet, on Amazon Mechanical Turk, and we said, tell us what these different groups are about. And they told us this one's about food, this one's about music, this one's about medicine. So these topics covered a wide range of things that you'd come into contact with in everyday life. Now, 2 of these topics, they told us, were about business and were about politics. And what we found is that if we applied the strategy that I described to you before to each of these groups of 30 words, then what we found was it didn't work for any of them, apart from the one group which had been labelled as being about business, in line with the results that we found before, but also another group which was labelled as being about politics. So increases in people looking for politically related information was also being followed by stock market falls. Now, in hindsight, the relationship between the economy and the political system is extremely obvious. But this isn't a relationship that we would have found without applying this broader approach. So the results I've described to you so far are based on historical analyses. And so this is a caveat to what I'm telling you here. The takeaway message is absolutely not that everybody should go home and try and trade on these strategies and that they're guaranteed to make you rich in the future. Of course, that wouldn't make any sense. But the results that I've shown you here, I think, do give a sense of the potential for combining these online traces of us looking for information with data which can give us insight into events of real impact in the real world. Now, the results I've shown you so far are mostly based, or entirely based, on textual information. So what text are people looking for online? But increasingly, the information that we share is not just textual. For example, increasing volumes of photos are being uploaded to services like Flickr and Instagram. And there's an awful lot of information in those photos. So, for example, the map I'm showing you here was created simply by plotting the location of 32 million photos which were taken and uploaded to Flickr in 2012. So we looked at this data and wondered what we could do with it. And in fact, an awful lot of money is invested into trying to understand how people move around the world today. For example, if any of you have ever travelled to the UK, you might have been stopped at the airport by somebody with a clipboard who's asked you, where are you going? Or where have you come from? And where did you spend the past year? So we looked at this data and we wondered, well, could we do all of this without clipboards? Might we be able to just work it out from the Flickr data? And so with Daniele Barchiesi, who's a postdoc we're very lucky to work with at UCL, we looked at Flickr users who'd taken photos in the UK between 2008 and 2013. And Daniele looked at where these users had taken photos in the previous year and used that to infer where they might have spent the majority of their time in the previous year instead of asking them with a clipboard. And we compared our estimates of how many people may have travelled from different countries to the UK in that period with the data that the ONS had carefully collected as part of the International Passenger Survey. And what we find is a very close relationship between the number of Flickr users that we detect and the estimates that the ONS make from their survey. Now, this is great. You're probably not surprised to know that, of course, not all results are rosy. And what we found was that although this overall relationship is very convincing, if we look at the tiny changes from year to year in the numbers of people who the ONS report as visiting the UK from different countries, which are very, very small in comparison to the differences between countries, we have difficulty in capturing that in the Flickr data. We see small movements in the ONS data, and we see small yearly movements in the Flickr data. And at the moment, these don't match up. But interestingly, although it might not be obvious from the numbers on this plot, the ONS actually only survey about 40,000 people per year in order to come up with these numbers. And if you look at the Flickr data, we've got about 15,000 people per year who we're essentially surveying for free. So it's not clear whether the Flickr data is just not accurately capturing these movements, perhaps because it's sampling a biased set of people, or whether perhaps these movements are so small that the data that we're using as ground truth data is perhaps also struggling to accurately capture these changes from year to year. So this is an analysis of the metadata associated with the photos, the location and the time. But what about the content of the photos itself? So this is a photograph of the Lake District, which is a very beautiful area in the north of England. And many of us here are willing to spend money to go and spend time in beautiful locations on our holidays because we have this intuitive feeling that it makes us feel better. So with Chinuki Sarasinya, an absolutely excellent PhD student who we have working with us, we wondered, might we actually be able to find a relationship between the scenicness of a location and people's health? So what Chinuki did is took data from the census, which is a survey which is sent out to people every 10 years in the UK, and they're obliged to fill it in and send it back. And one of the questions on this survey is about people's health, which they have to rate as good, fairly good, or not good. And so we looked at the number of people reporting their health as not good across England, and we normalised it to take into account the age of people living in different areas, as well as their gender. Now, alongside this census data, we were very lucky to be able to use some data which had been collected on how scenic different parts of the UK would be. Now, this is a very subjective measurement, which would have, again, previously been difficult to collect because you would have had to go and ask lots and lots of people for their opinion in the same way as the ONS is doing with the International Passenger Survey. What we were able to use was data from a game online called Scenic or Not, where people take photos of each kilometre squared of the UK and they rate that picture as scenic, it gets a 10, or not very scenic at all, and it gets a 1. And if you plot that scenic data, then this is what you see. And so we combined this data with the data on health, and what we found was that, indeed, people consistently report their health to be better in more scenic locations. Now, a first reaction to this might be, well, yeah, obviously, richer people live in more scenic locations, and they've probably got better health as well. But in fact, we include in our model measures of different kinds of deprivation, so people's income, the housing, crime in that area, and you find that even if you put all of that in, people are still reporting their health to be better in more scenic locations. Now, in previous studies, people have shown or suggested that health is better when you live closer to green space, so where satellites are taking pictures of the UK and they're working out how green different areas are. And so if you plot green space, it looks like this. if you compare it to the map of scenicness, you can see there are some obvious similarities, but the maps aren't exactly the same. And so if we build models of the health that people report themselves they consider themselves to have, and we use green space to try and predict this, statistically predict this, or we use scenicness to try and model this, or we use both together, then what we find is that across the UK as a whole, scenicness, the data on scenicness is leading to much better models of people's health, or the health that they report. In particular, in cities. So on this diagram, purple indicates that the model with just scenicness is more likely. Green indicates that the model with just green space is more likely. And stripy purple and green indicates that the model which includes both of them is most likely. And you can see that particularly in urban areas, the purple bar is particularly large. And we see purple pretty much the whole way through. So these results provide some initial evidence in line with the interesting hypothesis that the aesthetics of our environment might actually have more practical impact than we previously realized. So to summarize, I've shown you evidence that internet users in countries with a higher per capita GDP tend to look for more information about the future. Increases in people looking for financial but also political information online tend to be followed by stock market falls. We can use data from photos that people have uploaded and left online to estimate basic characteristics of how people move around the world. And also, people report their health to be better in more scenic locations if we draw on crowdsourced data to understand how scenic different areas of the country are. So these are just a few examples of the kind of results our data science lab has been coming up with, which suggests that data from the internet might help us measure and possibly even predict human behavior. Thank you very much.
Thank you very much for your very interesting talk. Are there any questions? So, do we have a second mic here? Then maybe you can speak up and.
Did you? Yes. Go ahead. Pretty fascinating talk. I really enjoyed it. The one thing that I was wondering was, do you have the hypotheses before you look at the data, or how are you making sure that the hypotheses that you're deriving by looking at the data are actually being tested as the causal reasons and not just some spurious correlations? Because these days there are all these sites that are actually increasingly showing how many of the data science studies are just finding spurious correlations and how they're often not very careful about explaining contradictions.
Right.
So for instance, in the first part of your talk, you notice that Brazil, I thought, was actually looking towards the future when its GDP is not really that higher than some of the other things. So how do you deal with these issues?
Right, it's a very, very good question. Coming to the Brazil example, you're absolutely right. Brazil is an outlier in that relationship. The relationship is very strong overall, but you do see that Brazil is looking much more to the future than you would expect from per capita GDP. Now, this is something that we're continuing to investigate, but one possible explanation for this is the level of inequality that you sadly see in Brazil. And so it's possible that the internet activity that we're measuring is more driven by people with a higher economic resources, and so we start to see behavior which is more similar to the behavior we see in countries with a higher per capita GDP. But we were also intrigued by Brazil in particular. I think they were also quite happy to see that they were so forward-looking, but it's something we continue to look into. On the question of finding the hypotheses before we look at the data, in general, this is something we absolutely rely on. Now, I think the kind of data that we're seeing that is being generated by our everyday actions is a real gift to the social sciences. In no way is it going to replace data from carefully controlled experiments or carefully sampled surveys. And even though we're finding these results where we compare internet data to surveys, we would be the first to complain if the surveys vanished because we'd have nothing to calibrate against. So our hope is simply to see if we can use that data to come up with quicker, cheaper, perhaps measurements in between these larger surveys, which will give us a proxy measurement for what's going on in the real world. But we know, the Google flu example perhaps has shown recently, that the relationship between online data and real-world data changes over time. So we can't just use surveys that we've done up till now and hope that this continues to be the case in the future. So, in general, I think this data it's a real gift, but although it can save time, you don't have to take ages running an experiment, which many of us who've done that will know how much time is involved in setting up an experiment with humans, how much money is involved. But you can potentially really lose time by just randomly combining data with methods and actually just creating some more numbers that don't really tell us anything else. And so something we very carefully do, and something we very carefully teach our students as well, is to think beforehand, what does your instincts about the world suggest might be interesting behaviour that this new data might give us an opportunity to measure that we didn't have before. These hypotheses don't necessarily come from social science theories, existing social science theories, because it's not necessarily really easy to connect these two paradigms at the moment, but we hope to be creating building blocks that we can start to build more theories from in the future. The one exception to what I'm saying there is the study that I showed you, where we looked at lots and lots of different topics, where we were deliberately trying to ask what are people looking for before stock market moves. But there we very carefully controlled for the fact that we could have found spurious correlations. There are statistical methods which will let you do that, and so you can exploit this large amount of data if you use the right statistical seatbelts, I suppose, the right statistical methods to make sure you don't trick yourself into thinking things are there which aren't.
Any other questions? Okay, so in your last study, you have this impact of Scenicness and green areas on the behavior of people on social media. I was doing a study on the effect of climate and weather some years ago, and I found some significant impact on the behavior of people in Twitter and Flickr. So have you checked for that? Because for me it's quite obvious to me, like the weather and the climate influences how scenic an area, a picture looks, and also how much green you see on the satellite.
Okay, so something which is perhaps worth highlighting is that the data we've got on people's health, the health that they report, comes from the census. So that's data from all of the UK, which is collected from the census in this census process. Separately, we've got people looking at photos that have been taken of kilometre squares across the UK, and they're telling us how scenic they think they are. So it's not necessarily the same people, right? And so whilst we have looked at what else might affect scenicness ratings of these photos, for example, pulling out the colours in the photos, looking at brightness, saturation, contrast, you do see there are you can see some patterns in the photos themselves. So an increase in green tends to increase a rating of scenicness, but then that drops off. It's not just about the photo being entirely green. But it's two separate processes in the end. And so what we were keen to understand was whether the scenicness of the environment could really quantitatively be shown to have a relationship with something as important as how healthy people consider themselves to be. Because before it was so difficult to quantify that, and particularly given the results in cities, which is not just about a mountain and a lake being found in the middle of the city, of course. It's about different aspects of the city landscape being scenic. If this really can be related to people feeling better, where I emphasize it's a correlation, we can't show it goes one way, but there's a possibility it goes in that direction. If we find increasing evidence that there's a relationship between how beautiful an area is and how well people feel, then potentially that could be initial evidence that it might be worth investing more resources, at least in low-cost ways of making an environment more attractive, because that might actually serve to improve people's sense of well-being.
Question in the first row?
My question, how much money did you make with your Wikipedia study on the stock market? I mean, this is the ultimate test. And if it will become common knowledge, then the effect will certainly disappear.
Yes. So you've got a very good point, and this is exactly the case. And this is part of the reason that we give this caveat. Of course, if we go public with this kind of relationship, it doesn't mean that we expect it to continue to exist in the future. It's very, very simple, that relationship. It's about weekly data. In the first place, it was just about financial topics. And so it's almost the simplest thing we could have done. So it highlights the potential for doing slightly more complex things. But yes, you are absolutely right that we wouldn't expect it to work in the future. But we felt that on balance that we would get greater benefits from going public with that information.
There was a question back there.
It was exactly the same question.
Maybe one final question before we head into the break.
Well, this is a follow-up. You normally expect that if you discover a measurement that, of course, it alters the behavior.
Yes.
But in this case, it's something pretty fundamental. If assuming that companies can't fake how many looks there are on their page with, hiring people or something, which maybe is a ridiculous assumption. If you find something as fundamental as that, like 2 billion people do something on the web, predict something, then maybe that will be an exception to this rule of the measure changing the behavior. Maybe there's some things we can't actually change.
I think you're absolutely right that there are some things that don't change. I think that's a really important observation about the different kinds of behaviours that we're looking at. So, for example, if I announce very loudly that I expect there to be lots of traffic around 5 o'clock this evening, there's still going to be lots of traffic around 5 o'clock this evening. No one's going to act on my amazing prediction because it's still in their interest to try and travel at around 5 o'clock this evening, and that's why we see recurring traffic in rush hours every day. The stock markets are slightly different because obviously there's huge benefits in people acting on other people's predictions, and a lot of resources go into trying to anticipate other people's predictions. And indeed you can manipulate this data, and that's something that you have to bear in mind when looking at it. If people thought there really was value in setting up something to automatically look at Wikipedia pages or search a lot on Google, then that would potentially affect the kind of data that we're seeing. So these are all very important points that you have to take into account with these sorts of analyses. But your point that there are some things that we might not change because there are greater forces holding them the way they are is very, very valid.
Okay. With that, I'd like to thank you very much again for your talk.
Thank you. Thank you.